All right, so we have covered adding, subtracting, multiplying, and expanding like a shortcut from multiplying out, specifically binomials raised to powers, right? So we've done a lot with polynomials, but we haven't looked at division for polynomials. So that's going to be kind of our next topic, and we're going to look at two different ways that you can do division of polynomials. The first one that we're going to look at today is long division. Okay, so before we get into how to do long division with polynomials, let's just do a quick refresher on how long division works. So long division problem like so, right? You'd set it up where this goes inside of your little house here, and the number you're dividing by goes on the outside, right? And then what you want to ask yourself is, how many times can I fit 3 into 4? Well, once. So I put a 1 on top of it. Then I multiply 1 times 3 and get 3. Subtract, that's 1. Okay? Then you bring down the next number in your problem, the 6, and you do the same thing. How many times does 3 go into 16? 5 times. All right, 5 times 3 is 15. So I multiplied these guys and wrote that here. And then we subtract them and get 1. Okay, and then I bring down my last number and you get 2 here. And I do the same thing. How many times does 3 go into 12? 4. Multiply and subtract. Okay, and that right there is how long division works. Cool. All right, so this one worked out where we did not have a remainder, right? So that means that we had a straight up answer of 164. But what would have happened if this had been, say, a 3 here instead? Well, then when I brought down the 3, I would have had 1 left over, a remainder of 1, right? And now I don't know how much you remember how to do this part because it's probably been a while since you did remainders. Okay, but there would be a few different ways that you could write this problem as your answer, right? My answer, you could write 154, right? And then you could write like R1. That was something that you probably did at one point. But there was another way you could do this where you would say 154 and then 1/3, right? Because you have 1 left over and you need to divide it by 3. So it's 154 and 1/3 would be your final answer. Okay, that is the style that we are going to do as we write our answers for our long division of polynomials. Okay, so we're going to write the remainder divided by the thing you were dividing by. Okay, all right, so let's take a look at how this is going to look with polynomials. It's going to be very, very similar. So the first thing that we're going to do is you're going to write your problem in long division format. Okay, and it's really important that you include a 0 for any missing terms. Okay, we basically just use it as a placeholder. All right, but it's really, really important. It'll totally screw you up if you don't. Okay, and then at each step, you need to divide the term with the highest exponent. Okay, so you'll see what I mean in just a second. So let's take a look at this problem. So first thing I'm always going to check for is see if there's anything missing. I've got an x to the 4th, an x to the 3rd, but no x to the 2nd, right? So you need to add in a 0x squared just as a placeholder, just like how you put a 0 in the middle of a number to act as a placeholder. It's just going to help things get like lined up properly. Okay. Other than that, I've got an x, I've got a 1. There's no missing terms over here. If you had a missing term on this side, you'd add a 0 in as well. Okay. All right. So then I'm going to write this in long division format. So 2x to the 4th plus 3x cubed plus my 0x squared. Again, that's really important. Plus 5x minus 1. That goes in my long division bracket. And then I'm dividing it by x squared plus 3x plus 2. All right, so here's what you are going to look for, okay? So we're looking to figure out, I'm looking at the first term here and the first term here. Okay, so you're always going with the first term, the ones with the highest exponents. Okay, and what you're trying to figure out is what do you need to multiply this by to make it exactly the same as this? Okay, so I would have to multiply this by 2 to get the coefficient of 2. And I'm at x squared, I need x to the 4th. So I'm going to multiply it by 2x squared. Okay, so I'm going to write that up top. I'm going to put it here so that it's above its like term, just because I like to have things nice and lined up like that. Okay, and then just like in our division problem, now what you do is you take this, you multiply it by this, and write it underneath. So 2x squared times x squared is 2x to the 4th. Notice those are exactly the same sign and everything. That's what you're looking for. 2x squared times 3x. 2 times 3 is 6. X times x squared is x cubed. And then 2x squared times 2 is 4x squared. Okay, so we got that. So now what are we going to do? Well, just like in our long division problem before, right? We subtracted, right? I multiplied the 1 times 3 and got 3, and then I subtracted 4 and 1, right? So that's what we need to do next. And this is the most common screw up, okay? So we are subtracting here. And the most common things that happens is that people do this. Oh, 2x to the fourth minus 2x to the fourth cancels out, which is what we want to have happen. And then they'll say, oh, well, 3x cubed, and then they add 6x cubed. That's not what we're doing. We're subtracting. 3 minus 6 is negative 3x cubed. And then 0 minus 4 is negative 4x squared. Okay, so you just got to be really careful that you make sure you keep subtracting, because like I said, that's the most common mistake. All right, so then from there, just like in our other problem, the next thing we're going to do is bring down the next term. Okay, and then we're just going to rinse and repeat. So I'm going to do the same thing. What do I have to multiply x squared by to get negative 3x to the third? Well, I have to multiply by negative 3, and then I need one more x. So I'm multiplying by negative 3x. Okay, and I'm going to take that and multiply it by the whole thing. Just my new term. I'm not doing the 2x squared. Just this new negative 3x. I'm multiplying by this. So negative 3x times x squared is negative 3x cubed. Those perfectly match. That's what you're looking for. Negative 3x times negative 3x is positive 9x squared. Negative 3x times 2 is negative 6x. Okay? And then again, we're going to subtract here. All right? So these guys cancel. Negative 3 minus negative 3 cancels. Negative 4 minus 9 is negative 13x squared. And then 5 minus negative 6 is going to be 11x. I just realized I messed something up, hence the awkward pause. Negative 3 times positive 3 is negative 9. That should have been a minus 9 there. So then negative 4 minus negative 9, so negative 4 plus 9, this would have worked out to be 5x squared. See, if we were in class, y'all would have called me on that and been like, Miss King, you put a wrong sign there. And then we would have been fine, but oops, I missed it. It's all right, we caught it. Okay, so then the next thing I'm going to do is bring down the next number, and we're going to rinse and repeat. So what do I have to multiply x squared to get 5x squared? 5. And then big distributive property, I'm multiplying that by this whole thing. So 5 times x squared is 5x squared. Those perfectly match. That's what we want. 5 times 3x is 15x. And then 5 times 2 is 10. And again, we're going to subtract. So those cancel. 11 minus 15 is negative 4x. Negative 1 minus 10 is negative 11. Okay, and then at this point, we are done with the long division part. And the way that I can tell is that x squared, I can't multiply x squared by anything to get just an x. I already have too many x's. I would have to take some away to get here. Okay, and also if you've been lining up your like terms, this is usually about where you hit the end. So the last thing that we need to do is write our actual answer, okay? So our actual like final answer for this one. Totally forgot how to spell answer for a second there. All right, so your final answer is whatever is up at the top, so the 2x squared minus 3x plus 5. And then plus, and we're doing the fraction setup, right? Just like we had the 1/3 in that other example. So plus the remainder, negative 4x minus 11, divided by the thing you were dividing by to start with. Okay, and that is your final answer. Okay, so really quick, right? Where did that come from again? So this went here, right? That one in the top of your fraction. This was what we started with. So this went here. And then this went here. Okay, so that's where those are always going to go, and it'll always be in that order. All right, so let's do one more example of this. So this guy right here, so I'm going to go ahead and set this up. All right, and the first thing you need to check for is any missing terms. Well, when I look at this, I start with 4x to the fourth, and then I got a big gap, right? I need to add in a 0x cubed and a 0x squared. All right, and then I got my 5x minus 4, and that one's all set. Okay, so remember, you got to add in those 0 terms. It's going to really screw you up if you don't. Okay, so 4x to the fourth plus 0x cubed plus 0x squared plus 5x minus 4. And then I'm dividing that by, I should have left myself some more room here, x squared minus 3x minus 2. I have all this space, and I didn't use any of it. All right, so first thing I'm doing is I'm figuring out what do I have to multiply x squared by to get to 4x to the fourth. Well, I have to multiply by 4, and then 2 additional x's. So 4x squared, and I just like to put it above its matching term. Okay, and then giant distributive property. So 4x squared times x squared is 4x to the fourth. Those perfectly match. That's what we want. 4x squared times negative 3x is negative 12x cubed. And then 4x squared times negative 2 is negative 8x squared. Okay, don't forget we're subtracting, so that cancels. This is especially when there's zeros, people tend to screw this up. 0 minus negative 12 is positive 12, x to the third. 0 minus negative 8 is positive 8, x squared. Great. All right, so then I'm going to bring down my next term. So I'm bringing down the plus 5x. And we rinse and repeat. What do I have to multiply x squared by to get to 12x to the third? Well, 12x. 12x times x squared is 12x to the third. 12x times negative 3x is negative 36x squared. And then 12x times negative 2 is negative 24x. All right, and then we subtract. These guys cancel. 8 minus negative 36 is 44. 5 minus negative 24 is 29. All right, bring down my next term. So bring down the minus 4. Then we do the same thing. What do I have to multiply x squared by to get to 44x squared? 44. So we're going to have some big numbers here. 44 times x squared is 44x squared. 44 times negative 3x, you can use a calculator, negative 132x. And then 44 times negative 2 is negative 88. Okay, and then remember we're subtracting, so those cancel. 29 minus negative 132 is 161x. Negative 4 minus negative 88, so that's plus 88, so that'd be 84. Okay, and then I'm done. And again, I know I'm done because there's nothing I can multiply x squared by to end up with fewer x's, right? At least not a polynomial. And then I'm also kind of at the end of my row, so that's sort of a hint too that you're done. Okay, so my answer for this one, so again, it's whatever you got at the top, so the 4x squared plus 12x plus 44, and then plus your remainder, 161x plus 84, divided by your dividend, the thing that you were dividing by to begin with, x squared minus 3x minus 2. Okay, and that is my final answer for this one. And one more time where these came from. So this goes here, this goes here, and this comes down the bottom of your fraction. And that's how you do polynomial long division. So it's not too terrible, but it is long. So much like when you first started doing long division in third grade and you were like, oh my gosh, it's so much work. Same thing with long division. Okay. The good news is there are some shortcuts that you can take, which we're going to cover at a later time.